today we're going to discuss about what is Kruskal algorithm together with my team. By the way, I'm Erl Jay Montalban.
And I'm Richard Canja.
And I'm Ryl John De Jesus.
Kruskal algorithm is a minimum spanning tree algorithm that takes a graph which form a tree includes every vertex has the minimum sum of weights among all the trees that can be formed from the graph. This algorithm was described by Joseph Bernard Kruskal Jr. in 1956. Kruskal algorithm initially placed all the nodes of the original graph isolated from each other to form a forest of single-node trees and then gradually merges these trees, combining at each iteration any two of all the trees with some edge of the original path.
Next is the definitions. First, spanning tree. Spanning tree given a connected and indirect graph. A spanning tree of that graph is a subgraph that is a tree and connects all the vertices together. Second, minimum spanning tree. The spanning tree of that graph whose sums of weights of edges is minimum. A graph may have more than minimum spanning tree.
So here are the steps on finding minimum spanning trees using Kruskal algorithm. First, remove all loops and parallel edges. Second, arrange all edges in the increasing order of weights. Third, pick the smallest edge. Check if it forms a cycle with the spanning form so far. If cycle is not formed, include this edge, else discard it. Fourth, repeat step 3 until there are v-1 edges in the spanning tree.
So here are our given example. First step state that we need to remove all loops and parallel edges. In the edge AC, there is a parallel line having two weights with only one edge, which is 5 and 9. So we need to remove the highest weight of edges between two vertices. Another, we also have a loop which occurs in vertex B with the weight of 6 and vertex D with the weight of 11. First step states and needs to remove all loops and parallel edges. Any edges that starts and ends with only one vertex is considered and it is a loop. For more further explanation, let us simulate and see the first step of Kruskal algorithm. In addition, these elements are the components that will build our spanning tree. First, the vertex. We have S, A, B, C, D, and T. The weighted cost of edges. Lastly, the edges. We have SA, SB, AB, AC, BC, BD, CT, DT, and CD. Second step states we will arrange all edges in their increasing order of weights. We have same weight cost in the edge SA and BC. Either of the two edges, we have SA with 2 and BC with also 2. Next, we have also same weight cost in edge AB and BD, so either of the two again. We have edge AB and BD, with the same weight cost of 3. Another next cost is 4. We have edge SB. Next, edge AC with a weight cost of 5. We have also the same weight cost at 6 with 2 edges. As I said, either of the two. We have edge CD and DT. Finally, the last edge with the highest weighted cost, 7, is edge. In the third step, we will check all the edges in the spanning tree, and if it forms a cycle, we will not include that in our spanning tree, and if cycle is not formed, we will include those edges. We have edge SA with a weight of 2. Since it is the first edge we visit, no citation of cycle form, so we need to include it. Another edge BC, also with a weight of 2, cycle is not formed, so we include this edge. And the edge AB with a weight of 3, cycle is not formed, so we include this edge. Also, edge BD has a weight of 3, cycle is not formed, include it in our spanning tree. In edge SB with a weight of 4, we notice that a cycle is formed, so we will not include it, else discards it. Edge AC with a weight of 5 also has a cycle. We will not include it, else discards it. An edge CD also form a cycle with a weight of 6, so we will discard it. Edge DT with a weight of 6, there is no cycle form, include it with our spanning tree. Edge CT with a weight of 7, we notice that it forms a cycle together with edges DT, BD, and BC, so it will be discarded. Finally, we are done finding our minimum spanning tree using Kruskal algorithm. You may add the total minimum spanning trees. Adding all the weights, the total weight is 16. Thank you for watching. Hope you learn and understand how we find the minimum spanning trees using Kruskal algorithm.
Absolutely.